Hello everyone, welcome back. This is our first video in a data structure and algorithm concept series. In this video, we'll try to cover the basics of data structures and algorithms, like what exactly mean by data structure, what are the different types and categories of data structures, why are they so important by taking some of the data structures and relating them with the real life examples, and we'll also try to understand what is algorithms and how they are related to data structures, and how choosing the right data structure helps to run the algorithms efficiently. So yeah, let's understand the concept about the data structure and algorithms. Let's start. Before starting on what exactly is data structures and algorithms, I want to quickly cover the primitive data types. I can cover this type in more detail in another video, but just want to give a very basic idea about what exactly means primitive data types. And because before understanding the data structures, right, we need to understand data, right, or data type. So it basically acts as a fundamental building blocks for data in your programming, right? So how you represent the data in your programming, right? And so if you see on the right side, right, in most of the programming languages, these are the common primitive data types like integer, boolean, character, and floating point. But different programming languages can like also have a non-primitive data types, which are kind of built on top of this. For example, string, right? You can define a string in Java or C Sharp, etc., right? But if you see, string is nothing but the array of characters. So it is built on a character data type, right? So, so basically, this primitive data types act as a foundation for building a more complex data structures, right? Like the one which I just now mentioned, strings, right? So uh, each these primitive data types, size of the primitive data types is almost fixed, but it can change depending on to the programming language. Like integer is 4 byte, but in a programming languages like Python, it is Python treat a variable as a dynamic, right? So it can expand, but internally there will be a Python interpreter or some other interpreter, depending on the language. It will convert that to the format which machine understands, right? So uh, the size can change, but again, this base data types is are are basically help us to understand the type of data we are storing, right? Because CPU does not understand integer, boolean, character, etc. CPU just understands the binary data. But for us to be able to write the application or code or logic, right? We need to understand this in more human readable format. So that is why this primitive data types concept came. And this data types acts as a very fundamental building blocks and a foundation for building a data structures, which we will discuss in the next slide. Uh, so what is meant by data structures, right? So we understood, okay, these are the data types and we can define and all, right? But depending on the application or depending on the problem statement which we are trying to solve, we need to organize, store, and manage the data very efficiently. And data structures provide us that way, right? Like uh, if I want to store the data for some phone book, right? I cannot just dump the data like that, right? I need to use some specific data structures so that some of the capabilities like searching a number in a phone book, right, can be done very efficiently. So these data structures are, so it is very important to choose the data structure based on what purpose we are trying to solve. So different data structures are suitable for different purposes. I'll explain the use of some of the data structures with some real life examples. But data structures is nothing but basically helps us to organize the data in a such way that our application or our logic works or manipulates that data or operate on that data very efficiently, right? So data structures, mainly there are two categories in it, like the base categories, like linear and non-linear. So linear data structures is basically where your data is stored sequentially, right? Like first element connected to second, second is third, fourth, etc. Like it's a linear, right? Sequential. Non-linear means that if first element might be connected to many elements, right? Or maybe all the elements are connected to each other. So it's a non-sequential structure, right? So in a linear, there are two types of linear data structure. One is a static and one is a dynamic. So in a static linear data structure, the example is array, where basically your size is fixed. So your program, you say, declare an integer of, let's say, 50 numbers or 50 size, right? So you are saying it is fixed, and that is what compiler also expects. Otherwise, it will give an error, right? If you don't specify the size, right? So that is why it is called as a static linear data structure. And in a dynamic, these are the three main data structures like stack, queue, and linked list based data structures, where dynamic means that you don't need to specify the size in a program itself, right? Based on your program logic, this structure can expand or reduce. Like you can add the elements to it or remove the elements from it, etc. Right? So there is no fixed size for it, right? So it can change based on how your logic is working and how you want to use it, right? Uh, in a non-linear, there are two types of base data structures. One is a tree where you will have some root element, and then there will be like children elements to it, like a root, and then maybe three or four elements connected to it, right? So it's like a tree-like structure, like the one we see family tree, right? Something like that. So uh, the second data structure in non-linear is a graph, right? So a graph is, you might have seen uh, like the Facebook and how friends are connected. You might be friend to person B might be friend to person C, and person C might be friend with you. So it's basically everyone is might can be connected to each other, right? It's a graph basically, right? These are the base data structures, but it doesn't mean that these are the only data structures. So using the combination of these data structures, many other data structures are built on top of this, like hash table, right? It is built using array and linked list, right? Combination of that internally, so array so that it can search the element using index fast, and linked list because it can expand dynamically, right? So tree, there are different types of trees, like binary search tree, you might have heard of, and AVL tree, etc. The way data is stored in a tree, the different subcategories are divided based on that. But the base data structures are this, right? Uh, so why the data structures are so important, right? Uh, See, like as I explained previously, right? When let's say you have some application which is searching through a phone book, right? Now, if you don't store the phone book efficiently or organize your phone book efficiently, then the application which is trying to, let's say, search some number in it, right? It will not work efficiently. It will slow down the application, hang, and that experience won't be good, right? So these data structures, different types of data structures are suitable for different problem, right? So it doesn't mean that it's the one data structure will be useful in all applications. No, it depends on the problem statement you're trying to solve. So we need to understand the concept of each data structure and think in a way that, okay, if I organize my data using this data structure, will my algorithm or will my logic work very efficiently or not, right? So for example, phone book, if I store that as a dictionary, or if maybe a dictionary where let's say name is a key and number is a value, something like that, which is nothing but again a kind of a hash table. So where I can efficiently extract using just a name, right? It's a O of one complexity. But if the same phone book, if I store it as a, let's say, linked list, right? Searching through linked list, let's say there are 100K records in a phone book, like it will be very, very slow, right? So that is why data structures are so important. And more important is how you choose the data structure, right? So let's understand some of the data structure examples with the real life examples. For example, array, right? Uh, One of the example is the calendar application. So use case is basically you store the events for each day of the month, right? Now, if you want to see for particular date what events are there, you just click on the date. It will just show the events, right? Uh, Again, like array is not the only way to solve this problem, but array is one of the suitable data structures to solve this problem, right? So it is possible that different data structure can solve the same problem efficiently, but uh, here the explanation is basically array can also be used to extract this or solve this problem efficiently, right? Then the linked list, right? You might have seen the music playlist or the YouTube playlist, etc., right? Like you can add the song to playlist, you can remove the song from playlist, and it provides you the efficient insertion and deletion, etc., without shifting the elements, right? And when you click the because deleting from array is not is difficult because it's a fixed array. It's not something the dynamically expanding array. So it is a fixed continuous memory, right? So linked list is helps here, like so that you can remove the dynamically, add dynamically, etc. Right? Stacks. You might have seen that in editors, right? Like you, let's say you type something and you feel okay, no, this was wrong. Then you do Control Z, right, or do undo. So it means that how does it go back to the previous state, right? Because each state it stores into the stack, and stack gives you what was the last operation done, and when you do Control Z, it will just go to the last operation, right? So it's basically last in, first out. Whichever last thing you have done, it will come as a first, right? So in this is one of the example where stacks can be used. Queue is basically in a very real life. You might have gone to airport security line, right? Or maybe let's say ticket booking in a theater, right? It's like uh, it ensures that whatever the processing is done in a order they arrive, like first in, first out. So that is the principle of the queue, right? Um, Trees, as I explained that you will have some root element like username folder is the root here, but if you see it has lot of subchildrens like local, then like you can see the structure hierarchy, right? So you can achieve this using trees, right? And it helps you to search efficiently, go to the particular hierarchy, particular directory, if I say specifically in a file system terms. So trees are can help you to efficiently do this in this scenario, right? And then the graph, right? So as I explained that in social networks is one of the very good example of the graph, one good example or scenario where graph is used. So like representing the connections between the users, like friends, right? So it efficiently basically transforms the data for operations like find my friends, right? Like friends of friends, etc. Right? So the graph model helps in such cases, right? So these are some of the data structures examples with real life examples, right? And you can understand why they are used in that scenario. right? Then algorithms, right? See, data structures helped us to organize and store the data efficiently. But algorithms define the steps to operate on that data, right? Efficiently. Like uh, you stored the data in, let's say, some kind of array or something, and now you need to use that array data structure, but you need to use it in a such a efficient manner that what are the output you are expecting from that array data structure is given very efficiently. And these algorithms define that set of instructions, right? So, but for algorithms to work very efficiently, the algorithms and data structures go hand in hand. So you need to choose the correct data structure to store the data, which will help you to optimize the algorithm performance, right? For example, like let's say you have a requirement to sort the numbers, right? Now, you can store those numbers into the data structure, array data structure, right? Uh, then what is the algorithm here? You need to sort the numbers. Now, there are different types of sorting techniques out there, like bubble sort, insertion sort, or merge sort, etc. Right? Which defines the logic efficiently so that it can manipulate the data which is stored in array uh, efficiently and sorts the array, right? So it uses the the properties of the data structure very efficiently, right? But if I store the same numbers in a list and try to sort it, it is very difficult, right? Like difficult in the sense it will not be that much performant compared to the array, right? So because linked list does not have an indexing mechanism, it is the memory reference, right? Uh, so sorting a numbers using a list and sorting a numbers using the array, it totally changes the or impacts the performance, right? So it, for algorithms to work very efficiently, we need to make sure that we are choosing the correct data structure and manipulating the data structure to get the output, desired output very efficiently, right? So yeah, this was basically the understanding the data structure and algorithms as a concept, different types of data structure and their uses in real life examples. So this will act as a base knowledge for our next videos. So in this video, we learned about basics of data structures and algorithms and how they are related to each other and how they are important. This will act as a base for our next videos where we will go into each data structure in more detail. If there is any other topic which you want me to cover or if I miss something here, please do let me know. I'll try to cover or address that in the next videos. I hope you understood the explanation and if you like the video, please subscribe and share. Thank you.